Hello everybody and welcome back. So we are about to do some scripting here, and I just covered that I don't find this to be a sufficient way of doing the cogwheel, and we're going to do it a little bit differently. So I just also explained about this different radius, why we use them, and we're going to use the middle when we measure the cogwheels. And that's the pitch radius. So we got the root, pitch, and the top. So in this one, we're going to start. We're going to do this part. This is our cogwheels. They're a little bit tighter and they look a little bit nicer. So what we're going to do here, we need to have this in detail, because when it's in points and we don't have any points on it, it won't run, because you can see it is like a loop. But now when we have detail, it says here only once. So that's lovely. So we're going to have int, and we're going to call this for cog amount. We're going to do cog amount like this. I think I want cogs like this, so we can have it here. So let's say we want, and I did float instead of integers, so I need an I here. So I'm just going to remove this one and do. I'm going to do it again, and now we have cogs. So let's say we want 10 cogs. So what we're going to do, we're going to make our own circle here. And so we're going to use a for loop. As long as the index is less than cogs, we're going to do another index. Like this. So we're gonna do a step. The step gonna be, we're gonna do 360 divided by cogs. And this gives us if I do like this, then we can save it. So now if we look here, you can see A is 36. So we have 36 degrees for each point. So we will make a circle with a 36 degrees step, but we need it as radians, like this. So we're gonna have it like this. So now we see this is the radians value. So in here I can do angle is equal, float angle is equal to do step times I. So this value is a radians angle, let's call it t. So now we're going to make a position of it. So we're going to do vector, and we're going to make this to the position, and we do set. And we're not going to bother about, cost going to be for the x. So we're going to do t here, and then we're going to do sign for the I, but instead we're going to keep it as it is. So and then actually we're going to do the float radius here, and if we do radius like this, and now afterwards we can control the size of this. So we do radius, and then here we just do int new point is equal to add point, and we're going to add it on this node, and we're going to also add this position, and this should be an equal sign, and then we need to do the radius bigger than 1 because all the points is in the center. And now you can see that we have all the points in a circle. And the reason we're not making a circle like this and use these ones is because we're gonna do these points here, we're gonna do them a little bit tighter. What I mean by that is that, first we just make a circle of this. So what we're going to do next is we're going to add a vertex. And then actually we need a primitive before. So we're going to make a prim, and we're going to add prim, and we're going to add it on this node, and it's going to be a polyline primitive type. So here we can add vertex, and we're going to add it on this node, and we're also going to add it on the prim we just created, and we're going to use the new point like this. Now you see, now we made a circle, and we just need to do this again after the loop, but here we do the first point that we created. So now we kind of made it complete. So and what we're going to do here, we're going to make this labs thicken. And if you don't have this labs thicken, you need to install the labs. Where is it? Here, maybe. Shelves, side effects labs, where it should be here somewhere. Yeah, you find it out here in the labs package stuff. You need to install it. So now you see we're kind of giving it's kind of like a tube like this. And if we reverse this, and now and we can do some normals to it. And now we can use this thing that we did here, group and poly extrude thing. So if we place it here, so we made this group where we pick each second cog, where it's going to be extruded by one of every two, and we made it group name extrude. And then in poly extrude, we do fetch the group, and we just extrude like this. And now maybe you figure out that, okay, but we do 10 cogs, but we only get 5. So here we just do times 2, and now we have 10 cogs. And now we can actually add another one here, and we're going to do float cog height. It is going to be the cog height like this. We want it to be like this maybe. Now we can just right click, copy parameter here, and then in the poly extrude, we just do distance. We do paste relative reference. And now also going to make this green here. And I do this dark green. And then, because now this cog height here is controlling this node here, I do this light green, something like this. Yeah, this one. And then I know that this one is controlling this one down here. So now you see we're starting to get this really nice procedural. But still, we're doing it. We could do the same thing with using the circle. But now this is why we made a fuss about doing this, because now we need to do this. We're going to do a float offset point. And we add this one here. And what this one going to do, we're actually going to offset each cog. If you imagine here, so this one I want to drag out to be here, and this one I want to drag out to be here. That in that way we're going to have much more tighter cogwheels. So the way we're going to do that is we're going to offset it. So the same way we do this one of every second. We can use the same logic in here. So if we do like this, if the index, oh, I just forgot what that is. Is that fract? No, what is it? Modulo, it's called modulo. So we do the index modulo of 2. And what's really good about that, if it's equal to 0, then we can have some logic. Else, if it's not, we do something else. And this is really nice. Now we can actually just offset the t. So t is offset point like this. Or t plus equal offset point. And now if we use, so if I use this one now, you can see we kind of offset it like this. This is really nice and handy because now we can have much more tighter. Let's see if we can borrow these here. So now we can actually just have much more control this one and make them much more tighter and nice. This stuff here that we made is so worth it in the end because it looks so more tight. So we're gonna do like this, and then actually, so now we see it kind of intersect a little bit, but we're also gonna be with this one here and control this one also. So maybe like this, you know. Looks pretty good, starting to look nice. And yeah, this is going to be in the details. It do a lot of difference. So let's add this one here, the inset. So we can actually, I would like to call this one to be, we can do this one to be float. Yeah, we're going to call it inset cog or poly extrude. And I'm gonna call it like sharpen cog edge. So it's more descriptive in here what it does. So I'm gonna copy this one, copy the parameter, and I'm gonna paste it in the poly extrude and paste it in the inset. So now, no, that's something worth if you do paste relative reference. So now we can control everything from this node. So we do a little bit, let's see here, like this. All right, so it's going really well. So in the next tutorial, I'm gonna move this down here, maybe I'll delete it. So in the next one, we're gonna continue and make it really awesome cogwheel and make the mesh in the middle, and later on start working with the rack. So thank you so much for watching and see you in the next tutorial.